This is Mr. Molo for lesson 10.8, polygons and tessellations. So some vocab for this one that we need to know are polygon, so a simple closed figure in a plane formed by 3 or more line segments. And then starting to get into some of the names of these shapes. So we have a pentagon, which means it has 5 sides, a hexagon, which means it has 6 sides, a heptagon, which means it has 7 sides, an octagon, which means it has 8 sides, a nonagon, which means it has 9 sides, a decagon means it has 10 sides. So we're going to be looking at a regular polygon. So a regular polygon has all sides congruent and all angles are congruent. Then we're going to be talking a little bit about tessellations. A tessellation is a repetitive pattern that polygons fit into with no holes or gaps. Alright, so kind of going with some of these shapes again. So we have triangle, rhombus, rectangle, parallelogram, trapezoid, square, pentagon, hexagon, octagon. Here's some examples of polygons, some non-examples of polygons, and why. So line segments are called sides. Sides meet there and only meet there. And points of intersection are called vertices. So all these are closed figure shapes. They all have lines and angles. Even the star would be an example of a polygon, even though it kind of has those points there. The ones that are not polygons is a circle. So it doesn't really have sides or angles or corners or things like that. This right here, this kind of semicircle would not be a polygon because of this arc right here. And this shape right here would not be a polygon because it doesn't have that U figure. It doesn't close that U right there. If they had another line up here, that would. And then this one would not be a polygon because there's more than one line intersecting right here in the middle of these two triangles. Alright, and here's some shapes. This is kind of important because a lot of you might not realize what some of these higher shapes could look like. So triangles, we would know. 4-sided shapes, we would know. 5-sided shapes, 6-sided shapes. Alright, things like this. But something even like this is probably what we're used to seeing for a nonagon. But even this could be a nonagon. As long as it has 9 sides, it's still technically a nonagon. Also over here with the decagon, this is probably what we're used to seeing for a decagon, but this odd arrow looking thing could still be a nonagon because it still does technically have 10 sides. Here's some more other oddly shaped things that would still qualify as polygons because they follow all the rules. So if we remember from a couple slides ago, so because we had kind of those two triangles together a couple slides ago, but they never touch here, so this is the difference between polygon and a non-polygon because they didn't touch. So there's no meeting of more than one vertex. Again, we're going to need to use this formula today to figure out the measures of these angles. For example, if you have a 12agon, so after 10 they really don't have names, it's just 11agon, 12agon, 13agon, things like that. So if I had a 12agon, so 12 goes in for my n, 12 minus 2 is 10, times 180, and then we're going to divide by 12 because that's my n. And so that means each angle of a 12agon would be 150 degrees. So summarizing, polygons are closed, flat figures, 3 or more sides. They have straight sides and they have to have corners and angles. So again, here's some more examples of non-polygons. So a circle doesn't have sides, angles, or vertices. This is not going to be one because it's not a closed figure. And this will be one because it follows all those rules. So it has closed figure, 4 sides, no curves or anything like that. So now with tessellations, we will predict which ones of these will tessellate or not. And really, just looking at the shape of them, are they going to fit well inside of each other? So a square is going to tessellate pretty nicely. This diamond here would tessellate pretty nicely. Circle, not so much. You're going to have holes, you're going to have gaps. Parallelogram would tessellate pretty nicely. Triangle, you could flip it upside down, will go pretty nicely. So we're kind of getting some ideas. X, probably not. It's not going to look very well if you try to put some patterns on there. So if we're looking at some tessellations here, so with this rectangle, I can make a pretty good tessellation. They're all going to be touching. I'm not going to have any gaps. It's going to make a very nice pattern if I wanted to continue that. But if I'm looking at this circle, You can see even just after 2 circles, I'm going to have some gaps there. Remember, with tessellations, you can't overlap them, so I can't say just put another circle there to overlap it to get rid of the gaps. So you'll see with just these 4 circles, there's lots of gaps already in between those 4 circles.